In this investigation, we're going to learn about the quotient of powers. So we need to review. Quotient means to divide. So if I have 3 divided by 3, well, that has a value of 1. Okay? So what is 9 divided by 3? Well, 9 divided by 3 is 3. Well, why is that? Well, if I break down 9, it breaks down to 3 times 3. And then that's being divided by 3. And notice how these 3's cancel each other out. And if we said before, 3 divided by 3 is 1, so when they cancel each other out, this is going to have a value of 1, leaving me with the 3 on the top. So 1 times 3 is 3, so 9 divided by 3 is 3. Okay, so what does that mean? Anytime I'm dividing something by itself, x divided by x, well, it's always going to have a value of 1. So you need to know that when it comes to this next investigation. So the quotient of powers. So 3 to the 6 divided by 3 squared. So I'm going to expand it out. And I've got 6 total 3's on top. And I have 2 3's on the bottom. And this 3 cancels this 3 out, leaving me with a value of 1. This 3 cancels that 3 out, leaving me with a value of 1. And so what do I have remaining? So I have remaining 3 to the 4th power. And you could leave it over 1, but there's no point in that. So what is the value of the missing exponent? 4. Okay, what about the next one? So I have 5 b's on top, and I have 3 b's on the bottom. That b cancels that b out. That b cancels that one out. And that b cancels that one out. So I'm left with b to the 2nd power. So what's the value of the missing exponent? 2. So do we see a commonality here? Well, if we go back to the very first property, a power to a power, sorry, not a power to a power. If we go back to the very first property, product of powers, product means to multiply. And when it was a product of powers, as long as we had the same base, we added the exponents. So, add exponents. Well, what's the opposite of multiply? Divide. What's the opposite of add? Subtract. So, it appears that every time we are subtracting exponents. So 6 take away 2 got me the 4. 5 take away 3 got me the power of the 2. So in this one, whatever x is, when I take y away from it, it has to have a value of 2. So x could be anything you want it to be. If x is 7, then what can I take away from 7 to leave me with 2? Then that means y has to be 5. So 7 to the what over 7 to the what has to be left with 7 to the 2nd power? Well, maybe that could be 7 to the, let's choose something different. Let's say 7 to the 4th power over 7. Well, if that's the case, then this one needs to be a 2, because if I've got 1, 2, 3, 4 7s on top and 1, 2 on the bottom, then those cancel out, leaving me with a 7 squared. So 7 to the 4 minus 2 is 7 to the 2nd power. So now in the last one, so it appears that we're subtracting exponents. So 3 to the 5 over 3 to the 5 is the same thing as saying 3 to the 5 minus 5, which is 3 to the 0. So what does that mean 3 to the 0 has a value of? Well, let's look. If I've got 1, 2, 3, 4, 5 threes on top, 1, 2, 3, 4, 5 threes on bottom, that 3 cancels itself out. That one cancels itself out. That one cancels itself out. Cancels out. Cancels out. But it's not leaving me with a value of 0 because every time they cancel out, 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3, 1. 3 divided by 3 is 1. 1 times 1 times 1 times 1 times 1 is 1. So 3 to the 0 power has to have a value of 1. So what is the missing exponent in this case? It was 0. But that leads me, the whole point of this leads me to the last and final investigation. So in this one, what did you notice about the powers? Well, our quotient power, as long as we have the same base, we can subtract our exponents. And so, go into this question here. Explain why it is reasonable to define b to the 0 is equal to 1 for any base. Well, let's go back up to what we just did. 3, so if we have the same base and its quotient we're dividing, we can subtract our exponents. So 3 to the 5 over 3 to the 5, we can call it as 3 to the 5 minus 5. And 3 to the 5 minus 5 is 3 to the 0, and anything to the 0 power is 1. Because if I have 1, 2, 3, 4, 5 threes on top, 1, 2, 3, 4, 5 threes on bottom, well, 3 divided by 3 has a value of 1 because they cancel each other out, leaving me with a 1. 3 divided by 3, cancel each other out, value of 1. Continue on. And so when I multiply all of that, it's going to leave me with a value of 1. So b to the x over b to the x, well, that becomes b to the x minus x, which is anything minus itself is 0. And anything to the 0 power is always going to have a value of 1. Why is it reasonable to define it as this way? Because when we divide something by itself, when dividing a number by itself, it's always going to equal 1. 3 divided by 3 is equal to 1. 3 to the first power over 3 to the first power, well, subtract those exponents. 1 minus 1 is 3 to the 0, and anything to the 0 power is 1. So when we divide a number by itself, it's always going to have a value of 1. 3 goes into itself one time. And they're canceling each other out, but it doesn't leave us with a 0. It leaves us with a value of 1. We're going to be using this property to learn 2 more new properties tomorrow. So hopefully things are going well at home. Remember to check in if you've got questions. And so at the end of today, you should have learned 4 properties. The product property, the power to a power property, the quotient property, and the 0 property.